Okay, what is the integral test? Again, it's about, let's say n, it's about the series with positive an. Also here, the an should be decreasing, which means that an should be greater or equal to an plus 1, positive. Okay, and if an happen to be equal to some function like this, then if this integral exists, which means is a number, not infinity, okay, then this series converges, and the difference between the value of this, this is equal to something. The difference between the value of this and L is smaller than A1. Let's call it, what? A, big A. The theorem says that A minus L, or the absolute value of this, is smaller than A1. A are positive, so A1. Okay, now let's do an example. We want to know whether this series is convergent or not. This new 1 over n to the power of p. This is p now. Okay, which is 1 over 1 to the power of p plus 1 over 2 to the power of p, 3 to the power of p, and so on. The general term is this, n to the power of p, and this is positive. If this was not positive, do the absolute value, work with that anyway. Now let's check if n plus 1 over is smaller than this or not. If p be positive, it is okay. So it is decreasing, and now this function happen to be exist, f of x equals to 1 over x to the power of p. Okay, which which for integer numbers would be equal to this sequence. You just substitute n here, that would be this. Okay, then we should calculate or check whether this integral exists or not. This is 1 over x to the power of p dx. Okay, what is it? It is x to the power of minus p. I should x to the power of minus p, which equals to the limit, because we got infinity here. Remember, from the integrals equals to the limit of x goes to positive infinity of x to the power of minus p plus 1 over minus p plus 1. From x, like this here, substitute x minus, then substitute 1 here. Let me erase. Now what is it? This is the limit x2 goes to positive infinity of x to the power of minus p plus 1 over minus p plus 1 minus, substitute 1 here, 1 over minus p plus 1. Okay, now this, when x goes to positive infinity, this would be what? This would be 0. Okay, not always. If minus p plus 1 be positive, if that be negative, this goes to 0, but if that was positive, that goes to infinity. So the whole thing would be infinity, in the case that minus p plus 1 be greater than 0, which means that p be smaller than 1. And at 1, this doesn't work, okay? Because 1 makes this 0. No, okay, at 1 this doesn't work, and the integral would be the ln of x, the absolute value of x. Okay, So let's just consider the cases, the values for p not, which are not equal to 1. Okay, so if p be smaller than 1, this doesn't exist, and so our series diverges n to the power of pi infinity 1. Okay, and if p be greater than 1, this converges to some value, and we couldn't calculate the value, but according to the test, this value, the difference between this value and this integral, which is minus 1 over minus p plus 1, should be smaller than a1. What is a1? a1, substitute 1 here, is 1 over 1 to the power of p is 1. Okay, which means whatever the value of this series would be equal to, let's call it L, the absolute value of L minus this, minus p plus 1, is less than 1. Which is a good approximation of the real value of this series. Okay.